Yes. Check. Clearly audible, visible. Am I clearly audible, visible? Yes or no? Yes. Okay. Previous example clear hai? A doubt? Static and fatigue loading? Hmm? Offline students? A doubt? Now? So, in previous lecture, we cleared the design of wedge joint, lap joint. Now, in this lecture, we are going to start design of butt joint. What is mean by lap joint? If one plate overlap over another plate and welding the edges, then it is called as a lap joint. Now, in this lecture, we are going to clear butt joint. So, butt joint means the plates are connected end to end, one after another, and welding with or without pressure and filler material. For example, beta, suppose assume thickness of plate as a T here. In case of lap joint, thickness of plate means S. In case of butt joint, thickness of plate means T. So if I weld by using filler material, by using filler material, so the plates are connected end to end, and using filler material or with or without filler material, if I join these two plates, then it is called as a which joint? Butt joint. So as its shape is like a V, it is called as a V butt joint. Okay. So V butt joint, and if I have to weld the plates having thickness, if the thickness of plate is more, then I have to use double V butt joint. Which butt joint? Double V butt joint. For example, fusion of edges. So after beveling the edges, we have to fill this by using filler material. So if the thickness of plate is more than 5 mm, then we have to bevel the edges. So This is T1 thickness and this is called as a T2. T1 plus T2 is the total thickness of the plate. Here T is the thickness of the plate. So length of the weld is visible in which view? Which view beta? Top view. If you have to check the length of this weld, then you have to check which view? Top view. In top view, it is clearly visible. This is the length of weld. This is nothing but the length of weld run. Thickness is visible in which view? Front view. And length is visible in which view? Top view. You have to check which view? Top view. So in top view, the length is available. Assume L as a length of weld and T is the thickness of weld. So this is called as a single V butt joint. Which joint? Single V butt joint. Single V butt joint. And this is called as a double V butt joint. So as its shape looks like a V, called as a V butt joint. If its shape looks like a U, called as a U butt joint, double U, square butt joint. Number of butt joints are there. Okay. So to the heading, design of butt joint. In previous lecture, we cleared design of lap joint. Lap joint and butt joint are the two main types of a welded joint. Lap joint and butt joint. Any doubt? Draw first diagram. So L be the length of the joint. So in examination, lap joint is generally asked. Okay, lap joint is generally asked in the examination, but as a part of our syllabus, we must have to clear the design of butt joint also. So draw this first diagram only. Single V butt joint. Single V butt joint. So write down. Consider V butt joint as shown in figure Consider V butt joint as shown in figure. Let L is equals to length of weld and T is equals to size or thickness of plate, or it is also called as a throat thickness. Throat thickness. So in case of butt joint, thickness of plate is nothing but the throat thickness. But in case of lap joint, thickness of plate is S and throat thickness is, in case of which joint? Lap joint. Okay, lap joint मध्ये वेगळं आहे, butt joint मध्ये वेगळं आहे. Butt joint मध्ये काय करतो बेटा आपण? In butt joint, the thickness of plate or throat thickness is nothing but the T. And this joint is used to support both tensile or compressive load. So I'm assuming the tensile load P. So this joint support both tensile as well as compressive load. So how to find the tensile strength of this joint? So tensile strength of single V butt joint is tensile load is equal to resisting area in tension into tensile stress. So which area resists the tensile load? Which area resists the tensile load? L into thickness is T into L. It looks like a rectangle. So area of rectangle is T into L into sigma T. This is the formula to find tensile strength of which joint? Single V butt. If the joint is double V butt joint, instead of single, if the joint is double V butt joint, then tensile strength is equal to, again, resisting area into tensile stress. So resisting area is, length is L, but thickness is T1 plus T2. So here, thickness is T1 plus T2 into L, length of weld, into sigma T. This is the formula to find the tensile strength of double V butt joint. Double V butt joint. So single V butt joint and double V butt joint. Now in case of double V butt joint, thickness is T1 plus T2. This is T1 thickness. Is T1 and this is thickness T2. Here only thickness is T. So T into L. So this is the area of weld which we have to consider while the tensile load is applied on the joint. So it looks like a rectangle. So its length is L and the thickness, throat thickness is T. So in case of butt joint, throat thickness is nothing but the thickness of plate. In case of lap joint, thickness of plate means S and throat thickness means T, which is equal to 0.707 times S. Okay, note down. Consider V butt joint. Consider V butt joint. Consider V butt joint. Consider V butt joint. Let L. Let L. Length of weld T. Size or thickness of plate, or it is also called as a throat thickness. So tensile strength of single V butt joint is resisting area in tension into tensile stress. Done? Similarly, tensile strength of double V butt joint. So let us check the papers, previous year papers from the site Government Polytechnic, Amravati, exam sale, paper set. Let us check the first paper from winter 23. This subject RAC will be given in the next semester. There is machine design. So question number 4B. Question number 4B and 4A depends on the bolted and welded joint. Check. Self-locking and overhauling of screw. Clear झालाय बेटा? Define the following terms with respect to bolt. Major diameter, pitch, lead, minor diameter, DC. त्याला score diameter म्हणतो. And two examples are there. And marks is, each question carries 6 marks. Okay. So attempt any two, 3 questions are there. So the first question is depend on our welded joint. Two steel plates 100 mm wide and 12.5 mm thick are to be connected together by double transverse fillet weld. Double transverse fillet weld takes stress concentration factor 1.5, means which loading, fatigue or static? Fatigue. Stress concentration factor is assumed in which loading? Fatigue loading. In static loading, stress concentration factor is 1. And the tensile stress is given as 70 Newton per mm square. Find the length of weld under static as well as dynamic. We have to consider both the loading, static as well as dynamic. Static means rest. Dynamic means in motion. So write down example. Question number 4B. Question number 4BA. Paper is 23. Question number 4B. A. Winter 23. Winter 23, question number 4BA. We have to consider both the loadings, static and dynamic. Done, beta? Okay. So lap joint. So there are three types of lap joint. One is the single transverse. Second one is the double transverse. Third one is the parallel fillet weld. And fourth one is the combination of single transverse and double parallel fillet. So out of which type is there? Two steel plates, 100 wide and 12.5 thick. So width of plate is equals to 100 and thickness of plate means T or yes. Yes, because we joint double transverse fillet weld. Fillet weld means lap joint. Fillet weld means lap joint. One plate is placed over another plate and joining the edges. So we join single transverse or double transverse? Double transverse means we have to weld both side of the plates, called as a double transverse. And this is nothing but the size of plate S. So I'm assuming the both plates of the same size S. Thickness of plate is 12.5. Width of plate is 100 Next. Are to be connected together by double transverse fillet weld takes stress concentration factor. Stress concentration factor is stress concentration factor is given as 1.5 and a tensile stress as 70. Tensile stress means sigma T, which is equal to 70 Newton per mm square. Find the length of weld. What we have to find? We have to find the length of weld under static as well as dynamic. Static as well as dynamic loading. So I'm assuming the first case as a static loading. So length of weld for which loading beta? For static loading. Length of weld for static loading. So for static loading, what is the tensile strength? Which load is present on this plate, beta? Which load is present on the plate? Assuming the tensile load, so which strength we have to check? Tensile strength. What is the tensile strength of double transverse? Double transverse fillet weld. Fillet weld means lap joint. What is tensile strength? 1.414. That is 2 times 0.707, 1.414 into S into L into sigma T. And for static loading, stress concentration factor is 1. So sigma T by 1. So sigma T is there, S is also there. From this equation we can find out L, but P is no. So what is P? P is nothing but the load acting on plate. Load acting on plate. So how to find P? So assume this is a rectangular plate. On which this tensile load is acting, P. So how to find the tensile load on this plate? Tensile area into tensile stress. So tensile area of plate is S, width is B, S is thickness of plate. So how to find the tensile load coming on plate? Tensile load on solid plate, P is equals to area in tension into tensile stress. Which area is under tension? S into B or B into S. So tensile load P is equals to 12.5 into 100 into tensile stress 70. What is the load present on the plate? 8, 7.5 into 10 to the power 3 Newton. Is it correct? So the load on plate is equal to 87.5 into 10 to the power 3. So the same load present on joint also. जेवढा लोड प्लेटवर लावाल तेवढा सेम लोड कशावर राहील? जॉइंटवर राहील. So load on plate is equal to the tensile strength of the weld. म्हणजे tensile load present on the weld. So 87.5 into 10 to the power 3, 1.414, 12.5 L into sigma T. So from that, design L. Design L. L is equals to 70.72. Correct? 70.72 is correct answer. Mm. 70.72 mm. So for starting and stopping of weld run, we have to add, yes, adding 12.5 mm for starting and stopping of weld run. So for starting and stopping of the weld run, 70.72 plus 12.5, it should be equal to 83.22, approximately 84 mm. Yes. So this is the length of weld for which loading? Static loading. Write down. Given लिया बेटा. Given लियानंतर tensile load on plate P. So this tensile load on plate is nothing but the load on which joint? Welded joint. So maximum tensile load on the plate. First find maximum tensile load. And the same load is nothing but the tensile strength of the joint. तेवढाच लोड आपल्याला काय करायला लागेल? जॉइंटवर अज्युम करावा लागेल जेवढा लोड प्लेटवर आहे. येस. मग तो P 87.5 and tensile strength 87.5 सेम. डबल पॅरल साठी डिझाईन केलाय बेटा आपण 1.414. सिंगल ट्रान्सफर साठी 0.707. ऑलरेडी डिझाईन. इझी. ओके, ज्यांचं झालंय बेटा. नंबर 2, लेंथ ऑफ वेल्ड फॉर डायनामिक लोडिंग. Length of weld for dynamic loading. Fatigue loading, dynamic loading. Assume stress concentration factor. Next, case 2. Done? Done beta? Write down. Case 2. Length of weld for dynamic loading. We have to assume permissible tensile stress sigma T as 70 upon, what is stress concentration factor? Stress concentration factor is 1.5. And in case of parallel fillet weld, stress concentration factor is 2.7. And in case of transverse fillet weld, 1.5. लक्षात राहील का? दिलं नसेल तर लक्षात पाहिजे. 1.5 and 2.7. So answer is (46.66) Newton per mm square. So now, therefore, tensile strength double transverse fillet weld, tensile strength of double transverse fillet weld 1.414 times S into L into We already discussed this formula in the design of lap joint. Single transverse, double transverse, parallel fillet weld. So P is assumed to be 87.5 into 1.414, size is 12.5, L is unknown, tensile stress is taken as 70 by 1.5. From this, the length of weld is equal to 1.106.0 mm. So adding 12.5 for starting and stopping of weld run. For starting and stopping of the weld run. So L is equals to 106.08 plus 12.5. L is equals to 118.58. So add 12.5 mm for starting and stopping of the weld. So during fatigue loading, during dynamic loading, the length of weld run is greater than the static loading. In case of static loading, the length of weld run is this. Check. It is 84. It is approximately 119. So length of weld during static loading is less than the length of weld during dynamic loading. The question competitive examination मध्ये. The length of welding during static loading is dash. The length of weld during fatigue loading. Equal, greater than, less than, none of these. So for static, less than. For dynamic, greater than. Easy? This question is asked in the examination for 6 marks. Okay? You already checked the paper. So this question is asked in the examination for 6 marks. Question number 4BA, 12 marks. Okay? And the second question is already solved by us. The cutter of broaching machine pulled by square threaded screw. Square threaded screw, Acme threaded screw, already solved. What we have to find, determine the power required to rotate the nut. Power 2 pi nt by 60. T1 plus T2. T1 torque required to overcome friction at nut and screw. T2 torque required to overcome friction at collar. Assume uniform wear or uniform pressure. Find alpha, find mu, tan alpha, tan mu, and put the value, get the 6 mark question. And this is 6 mark question from the welded or bolted joint. Explain bolt of uniform strength with net sketch and list various stresses induced in a screw fastener. Internal stresses, external stresses, and both. Because only you have to list out this. And bolt of uniform strength. 2 methods are there. Either increase the diameter of the threaded part or drill a hole in the shank so that the strain must be uniform. झाला बेटा? ओके. आणि हा चॅप्टर बाकी आहे आता आपला कोणता? डिझाइन ऑफ स्प्रिंग 10 marks and bearing also, bearing and gear is also for 10 marks. Okay. Now let us check summer 23 paper. machine design. Question number 4B. Enlist the stresses in a screw fastening. What is overhauling? Overhauling and self-locking is VV. Explain the method of determining the size of weld when the bracket carries an eccentric load perpendicular to the axis of the bolt. सिलेबस मध्ये डेरिव्हेशन नाही म्हटलंय पण विचारलंय म्हणून मी बाय डिझाईनच शिकवलेलं आहे. डिझाईन विचारलं डिझाईन लिहा, प्रॉब्लेम विचारलं तर लेट अस चेक example. One example is asked from the power screw, one is from welded joint and one is from bolted joint. 666. So this is a figure number 2. This question is available in figure number 2. This is figure number 2, already solved by us. Yes, this example is already solved by us. Yes or no? Single transverse and double. मी म्हटलं होतं बेटा तुम्हाला फॅक्टर दिले राहते पाहून घ्या. Assume stress concentration factor for transverse fillet weld and parallel fillet weld. For transverse fillet weld, for parallel fillet weld, already given in the and already solve केलेला आपण. L1 is equal to 75 minus 12.5 and L2 साठी strength of single transverse plus strength of double transverse fillet weld. L1 L2 कसं काढलं बेटा सांगा. P is equals to 0.707 S into L1 into sigma T plus 1.41 times S into L2 into tau. इथून L2 काढलं. And for static loading this formula is used. For fatigue loading, we have to divide it by stress concentration. This is for which loading? Fatigue loading, and this is for static loading. Easy? Already solved केलेलं. So this complete our chapter number 4th, power screw, screw jack, bolted joint, welded joint. Finish. From next lecture, we will start our chapter number 5th, that is design of spring. आता तेवढे लेंदी युनिट नाही आहे जेवढा हा होता. हा खूपच लेंदी युनिट होता है ना. वेटेज सारखंच आहे पण लेंदी भरपूर होता. ठीक आहे, काही हरकत नाही. नेक्स्ट लेक्चर मध्ये आपण नवीन चॅप्टर स्टार्ट करू. आता काही अडचण असेल तर मला विचारा. एनी डाऊट ऑनलाईन स्टुडंट्स? आणि तुमचं तर 28 नंतर आहे ना हॉलिडेज तुम्हाला.